Hello everyone, my name is Behnam. Today I want to explain a little about how to modeling of flow in HecRas 2D, the last version of 6.3.1. I record this video for the NTNU hydraulic modeling course, and I will explain a little about how to model a river reach and how to check the results and improve the results. For example, improve the mesh that we have, how to improve the other parameters that we have. So for the start, we should go, as you are now familiar with the HecRas software, you know that we should first make a project. So I recommend to first check the previous video that I upload for the 1D. So this is so I name it like, for example, Lardal. Be careful to not use the special letters in other language like Norwegian or German. So for starting, we should go to the Ras Mapper after also checking the unit as we discuss about it. The unit should be SI. So here for 2D modeling, we should introduce a terrain. And first, as you see, we have a message to add the projection file. Here we can have the projection file, or you can go to the just projects, set projections. This is the projection that we have, and you can see the zone is 32N. As I mentioned before, you can also find any projection file. If you have any problem with your projection file, or if you want to search for your projection file, you can just go to this website, specialreference.org, and then search your name, for example, or if you have this number, you can search it, or if you have the UTM, for example, this one, you can search it, and you can find the new, then go, you can find the new projection file. Then go to the terrain, create a new Ras terrain to introduce your TIFF file. Here you should go to the plus and come here. You have a TIFF file. If you have more TIFF file, you should add all of them and then tick the merge input to single raster. Then create it. It takes a little time. Then after that, you can go to the map layer and you can add the Google image or Google satellite, and also add other points that you have or other layer that you need. And as I explained before, in the geometries, you can see the geometries input and your mesh, and in the results, after you run the model, you can see the results. So now it's finished. And you can see the river that we have. So then I'm going to the, for example, add reference. If you want to add the same terrain as the terrain that you have, you can add a layer here. Or if you want the image, you can go to the Google satellite, for example, and then add. You can see it. In the options, you have some options like capacity. You can change the capacity. You can see the overlay of the images. and then save and exit. Then for introducing the 2D flow mesh, we should go to the geometry here or edit geometry. Now we should introduce a 2D flow area. So we click here and introduce the area that we want to model, the area that we think it's affect from our flood or from our maximum flow that we have. So for example, I like to model from here. So I try to make a zone like this. And then as I want to be a short one, then I just make like this. It depends on you. For example, I make it a big one now to be short and also fast, but you can use the real and accurate data. So now it's a geometry. For example, I just wrote a geometry, or I can write it like Lardal, and then, okay. If you are coming here to the Ras Mapper, you can go to the plot contours and make it as something like this. Now you can see the area that you have. I think we should increase it a little. Yes. Now you can choose the center line of the river if you want, or the banks easily by this. But as we don't need it, then I turn it off. But when you want to draw a bank or any line, I recommend to turn the contour lines on. And then we left click and go to the edit flow area. Here you can see the morning n value. We should calibrate this value, or we should measure or compute the best value of morning roughness that we have. We can use the morning n value, as you can see, 0.06 or 0.04. It depends on the case that you have. And for your mesh, we should here introduce the mesh. I just use it 10 by 10. Again, it depends to your accuracy and your model. You can increase it or decrease it, but as I want to be fast and almost good results, so I keep it as 10, then generate points in 2D flow. And then the important things, force mesh computation. Here you can see the information about the mesh. And then, okay, so now you can see the mesh here. So then we should introduce the boundary condition lines. You can see BC lines here. For the boundary condition lines, you can get these area, for example, as we know the river are here. Just look at how I introduce it. So it's the upstream boundary condition. And we need another one. It's a downstream. If you think you have water also here, then you can also introduce it as a downstream that area. We have here more important options like 2D area break lines. I will talk about it at the end of the video, and also the 2D mining regions. If you have a mining layer, for example, you measure mining roughness along the river in various locations that you can see, then you have a mining layer and you can introduce the mining layer to the model, and it's really increased the accuracy of your results. Then I save the geometric data. We can name it like geometry, and then OK. Then close it. Now we should introduce the unsteady flow data. So we are here, and we can see we have an upstream and downstream data. For the upstream, it depends on your project, but we can introduce a flow hydrograph as we have a discharge hydrograph. So here we can start from 65. So we run it for the discharge of 920. And then here we need to introduce the slope. So we assume the slope is 0.01, or you should compute it from the Ras Mapper. And then, OK. If you want to see the slope, you can come here. So this is your river. Just go to the ruler, and then this is an easy way to show that. But you should be careful. It's not. You can see the slope is 0.003. But it's not accurate because I just draw it without any details. If you want to draw it, you should, and also you should take along the rivers to see the slope that you have. So, but one easy way is this. Okay, here then for the downstream, you can have a normal depth. If you choose the normal depth here, you should introduce the slope that you have, or you can introduce a stage hydrograph. So here we have a message that you introduce normal. Do you want to change it? Yes, we want to change it to the depth. And then for the depth, we want to have it as a 1.24. So 1.24. I just copy paste it for some values. You can assume that your water level is constant, or you should introduce normal depth. Usually, I recommend to use the normal depth if you don't have a specific data, because according to the changing of the discharge, the water level downstream should be changed. It depends to the case that we have. If we have a backwater, for example, downstream, we have a sea or ocean, it's maybe we have a backwater, so we should be careful about these data, because after running the model, then we should calibrate the model. And calibration, we should have some measured data from the field. I don't use any measured data from the field in this example, but you should find the measured data and calibrate your model by matching or having a good agreement between the measured data and your model data. So I write it as a Q of 920. And then OK. So if you have an initial condition, you can add the initial conditions here, but we don't need it now. And I will also explain for you how to make a hydraulic warm-up, which is so important. And it's especially when you don't have an initial condition, then it is really helpful and necessary. And really, really, really necessary when you have a sediment in your model. Then we can go to the unsteady. file, save as we have the previous one. So it's 920, so Q. And then, okay. For the plan, we can name it 01 or 019 CMS. Especially if you have more plans and more run, it's really important to choose a good name. And then, as we don't have a sediment, we just tick these things. And it is really important to match the data or the date that you have here with the geometry, with the unsteady data that you have. So I choose it today. Time is 0, and then again today. Time is 6. We can go and check here unsteady flow data, hydrograph. We have like the time of 5 a.m. So just look what's happened. I can also change these things 1 second. 5 minutes. So this is the computational interval, delta t. This is the mapping output interval, 5 minutes. And its effect on the time, because it's overwrite or write the result. So if you make it less or make it higher, it's affect the time of your modeling. And hydrograph output interval, we can use as the input one that we introduced to the model as 1 hour, but we just keep it like that. And the computational interval, which is so important for the stability of our model, we can keep it as 1 second. And then we push the compute. So now you can see we got the error as I told you, because the time of the simulation here is not matched with the input data. So we should change it to 5. And then if we run it, it's run. But I would like to explain you about some important options that we have in flow modeling. If you click here, or if you are coming here, computation options. In options, you can see this is for 1D unsteady, this is for 1D, 2D unsteady. You can see the gravity and other parameters. We also have them here. I explained them here, which are more important. These are some values which we don't work with them usually, but you can go to the, I really recommend you to go to the HecRas manual or HecRas reference and read about the parameters, but some of them which are important, I explained to you. For example, you have various equation diffusion wave, which generally gives you more accurate results, but it is not recommended. If you have a sediment modeling, you should use most probably SWE, ELM. It's also faster, but it depends to your case, and you should calibrate your model and see the data, but I keep it as diffusion. The maximum iteration is 20. It's the maximum number of iteration that you can have. If you decrease it, you may have maybe faster modeling, but instead you also increase the instability. And also some other variables that you have here. So if you want the turbulence model, you can use the conservative or non-conservative in the reference. You have some recommendation. For example, if you use the SWEELM equation, it is recommended to use the conservative form. And there is, for example, a table in a HecRas manual that explain these things very well to you. An initial condition and initial condition ramp up fraction, I explained to you later. For example, you can put this one as 20 and this one as a 2. Just keep this as a 10, and this one is 0.1. It can be till 0.5. I explain you what is the definition of this, and then OK, and then compute. So we have an error here, an usual error. You can read it. Always errors give you some information that helps you. For example, was not created successfully. It's a normal error. You should close it and then go to the geometric data and then right click on the edit flow area and then force mesh recomputation again. This happens sometimes, and you have to recompute the mesh for running the HecRas. I would like to also here told you, if you right click on your mesh, you can go to the view options. Here you can see various options. For example, if you want to fill it, you can fill it, or other options that you have to change the view of the geometric data. Then I like to save it, exit, and here run and compute it. Now I explain you what is the hydraulic warm-up, which is very, very important in sediment modeling and also here. And I show you by a graph. Here you can see the models information and the runs and the warm-up that we had here. If you remember, I add 10 now. From -10 till 0, we have a hydraulic warm-up that you can see here. So let's go to the data. We have unsteady flow data and flow hydrograph. You can plot the data. And here you can see the data. I like to draw these. So we just use a assumption for the unsteady hydrograph that we have. So in the real scenario, you use a real hydrograph. But again, in the hydrograph, for example, I just try to show you the hydrograph that we have. The hydrograph that we use, it's like this. Here it's 65 and here it's 920. So the 10 values that we use is a hydraulic warm-up, and it's so usually if we want to avoid the shock to our model, so it is better not to start modeling from this high value of discharge. So it is better to start from like discharge of 0 and gradually we increase it till 65 discharge. So some researchers or some modelers use a synthetic hydraulic discharge at some values before that. But I really recommend to use this interesting option of HecRas, especially for the sediment modeling. It's really important to use it. So the first value that we use 10, it's just to increase 10 hours of modeling, which I add a lot because our modeling is just 5 hours and I add a lot. And what is the ramp? The ramp is the 1.1 is the slope of this till discharge of 0. The maximum of ramp value is the 0.5, which is like 45 degree. The angle of this, I think it will be 45, and it's the maximum one if you want to have a like mild slope or high slope. So I really recommend to use this. So this is discharge and this is time. So this is the value that I told you. I change it to 0 because I want to be so fast, and we keep it this one as a 0.1. And if you have so many runs with so many cores, you can also decrease these cores, because for HecRas it is really important to have a cores with high speed instead of having so many cores, like 60 cores with low speed. Then the other important things here, you can change the time step. Instead of fixed time step, you can change it to the adjust time step. Delta T in the HecRas is a model parameters, so you can change it, but it's not necessary to have it like 1 or to have it like 1.2. It's converge the results to a stable results. So you can use like 1 here, but you can also use 2. And then the minimum current should be more than half of the 2. And then you have a number of steps below minimum. For example, you can change it to 4. And maximum number of doubling, you can change it to 4. I also use this one to 4. Here you can see the maximum number of time step that HecRas or your model will use is 16 seconds. And then the minimum is 0.06. So if your results are not stable, then the model decrease the delta T to this value. And if it is stable, so for having a faster result, it may choose the bigger one, the 16, or between these values. I think 2 is a good value, but you can also use 1. It depends on your modeling or result, but both of them should be good according to my experience. Then you can have a result. Here you can see the results that you have. Here you see the number of your plan and some information here. So we don't have any error here, but if you run it, you can see the number of iteration here. It's 2, 3, or it reached 20. And if it reached 20, then you have the sales number of the errors that you have here, and you can find the sales number. So as I change the delta T here, I just run it to show you it is correct. You can see here we received the error. The advanced time step control requires that the minimum current is less than half of the maximum. So I change it to this value, and then you can see it's run. But I stop it because with the previous one it's done. Okay, now we are going to the Ras Mapper to see the results. You can go to the result and, for example, show the depth. If you play the depth, you can see it's changed. So if you want to change it, for example, go to double click on the color pattern, then here change it to 2. You can here have a different color depth, but the depth is this, or you can also increase the classes, then create ramp value and then OK. Now you can see the results again. Or if you want to see the vectors, you can use this one. Or if you want to see the animated vectors, you can add this one. This is also some options that you have for the vectors. Or here you have some other parameters. This one is useful. For example, you said, okay, our accuracy is not like 1 millimeters. I want to increase it to 1 centimeter. Then you delete this one and okay. And you delete the water depth below that value, like 1 centimeters. Another important thing that you should learn how to work with this. What is these options? For example, plot, if you tick this one, you can see the flow connectivity of them. So we want to evaluate this, the flow and the vectors, you can see them. Everything seems correct till here. So we have a wall here, but the water goes to the other side exactly at this time. So what's happened? As our mesh is large, then we have some cells like this one. Half of them is in the water and half of them is on the wall. Then the water from these cells coming here. And what's happened to the connective cells that I show you, it shows the connection of the cells. You can see the water one comes here, the water comes from here, these cells, and here. You have also other parameters to the gravitation. We have various vectors here. Each vectors show different options. The blue vector is a normal flow. The green one here is an intermediate flow depth. The yellow one is the shallow flow depth. Here, for example, the pink one is the critical depth, and the gray one is a backwater. It's like the hydraulic connectivity shows you the errors, which cells the water goes from which cells and coming from which cells. But I really like this one, especially for the not so professional modeling. And also you have others, for example, display arrival time or other parameters that you can use here, and they are useful. Then you have zoom to layer. You can zoom to layer like this and also see the results. If you right click on this, manage the results. Here you can add each results that you want for different geometry, or here create new results. So you have hydraulics or 2D hydraulics. In hydraulics, for example, you can use the shear stress. We should wait till this finish. or other parameters that you have. And you can also choose a specific time, or if you want to save it as a train file and open it in the ArcGIS, I recommend to use these options here, this one. So here, for example, we can see the results. So here it's a shear stress for a specific time. You can see it's 50, around 50. So if we want to change this, so like from 0 to till 60, you can see the results of shear stress. And if you play it, it's increased. Or you can see the results of fruit. Or if I right click on it, then go to the create new results and to the additional to the variable if you want to check your results. Here you have a cumulative iteration. If you click on this, especially for when you have a sediment, this option it's useful. Cumulative iteration or maximum water surface error. So here we don't have any special cumulative iteration, and actually it's not reading, but then on the cells you can see, for example, maybe here we have some values, or where is the problem with the mesh, and in the geometric you can show your mesh. Here you can see the mesh, and if you have like cumulative errors, cumulative iteration here, you know that you have a lot of iteration here. So there is a problem most probably with the mesh or with the slope that you have here, and you should fix the problem. I explain a little about how to fix the problem for the mesh. And then maximum water surface error. You can see the points that we have. For example, here we have a huge maximum iteration. It's a maximum point. So we can go and fix it. So one reason is that this cells is half of on the river ridge and half of them on the wall. Let me, if I can. So we don't have these results now. Okay, then I think we are finished here. So I close it. So then if you need to have another run for another discharge, again, go to the Unsteady flow data and change the parameters here, and then save as another flow data like Q620 CMS or cubic meter per second. So now I would like to show you the 3D results. So let's see the depth here. It's great. Then go to the 3D results and okay, yes. So here in the 3D view, we should zoom a little. And then by right click, you can turn it. And I play it, and you can see here, you see that we have a water coming from these cells, but we have a wall. So the height of wall is more than the water elevation. So we shouldn't have any water here. So what should we do? We should go to the geometry data, and then we have two options. First, to use break lines to modify the mesh, and then we can use the refine version for the define or refine a mesh. So I am going to that and show you how to work first with break lines. So what should we do for fixing this problem? We should have a break lines, and I recommend to make this at the starting point of your defining the mesh. I just do it now because I want first you learn what is the difference and what is your options. So we are going to the 2D break lines, and then I just make it so fast here, but you should have a details on that and put time to have a good defining. So I make it as a left break line, and then okay, then I should also introduce another one as a right. So right break line. It is very, very important, especially when you have it depends when you have another format of the river. You should define break line as the bottom of your bank and at the top of your bank or floodplain, and one at the middle of the river or the center line of the river. And how to choose the center line, I explained it in a previous video for the 1D modeling. You should you should go to the Ras Mapper and then choose the contour lines. For example, here you should go to the double click and you can use the contour line, and then you can see the various contours and you can easily find the bottom of the river. But now we just use these two, and then after drawing the two break lines, we are coming here to the GIS tools and then break lines, cell spacing. You can see the various break lines that we have here, minimum value of the distance from the break line or the maximum. For example, we can make it here as a 5 and here as a 5 for both, and then okay. And then I just right click on that and enforce break line. Here also enforce break line. You can see the mesh start from these lines, and you can also increase these values or decrease these values in that option that you have. But we have a problem here. It defines one important things for the HecRas mesh. It is really important that you don't have a very small edges like this one. It is better your mesh is between like 4 and 6 like rectangular, but you know, these small edges, it's not good for HecRas and you have error for that. But if you want to add or remove any points, you can go to the edit, add points or remove points. For example, this one, I just remove it. Then you can see we have a new mesh. So I just check if we have any other error. So we have another error here. So we can remove it or we can add another point or right click, full plot. So as you see, it seems the mesh is good without error. So we save it. or it is better to save as it another one and then go to the run unsteady flow. I change save plan as this one with break line. Okay. And this one with break line. And then compute it. So here, in this case, as we change the time step, we make a dynamic time step. You can see the model use various time steps or delta t like 8, 2, 4. So it's really useful for optimize the time consuming of your model. So I close it. And then let's go to see the results on Ras Mapper. So here we want to see the results of with break lines. So I change the contour to maximum of 2, then create, then OK, and then close it. I hope we can fix it. So as you see, it is really, let's see if it is improved. So we have it on 2 and 15, the previous one. Here we have it as almost 1 hour and 30 minutes, 35 minutes. But as we improve the results, we improve the mesh. Now we have it on almost 2 hour and 20 minutes. So if you do it in a really accurate way, just zoom it and make the break lines very well and use the break lines at the middle of the river, at the bottom of the bank and the top of the bank. You can have a really good results. Very well. The next options for define the mesh, it's instead of using break line, it's using the refine region. I just go to these break lines and delete the break lines here, delete the break lines, and then go to the edit flow and just make it as before. Then OK, then force to compute. Then you can see we have a previous mesh and then save it. So then after we delete the break lines, now we have a we have a normal mesh. So I save it and then exit. So for the defining the refine zone or define mesh, we should go to the Ras Mapper. And then geometry to the flow area, and then you can see break lines or refine mesh. I click here and right click, edit geometry, or you have it here. So we are going to the edit geometry now. We can draw a refine mesh. So for this purpose, I told you that it is good to have a contour lines. Then I click OK. Now you can see we have a contour line. I can also turn off this. So it is better to have a like So now you can see the refined mesh, and also in the geometry, you can see the points or the area that we have. So for the defining the refined region, we can go like this, and we define area with water. I just defined this area. To make everything faster, and then double click, then you have this. So region, I just call it as region 1, and then okay. So now you can go to the edit refine region properties. You can see the cell size. We can add it like 5 in X and 5 in Y. You can have a far spacing, near spacing. I think we can have it as 10 to be fast. And then you can go to the enforce all regions, and then have this area. Let me just turn off the layer. So we have this layer. So you can see the mesh start from this area, and then it's again the same. So it is I really recommend to continue it, because then you don't have problem to continue it. It's sometimes good for like a braided river, if you have various braided with with a coarse mesh or fine mesh. So I think I just want to show you how to work. So we just keep it simple as this, but please remind that it is really recommend to continue it till here. And if I want to model this with the refinement region, I will continue it to the end of the reach. So then stop. Yes, save it. And then you can see it's saved. And then save the total and then exit. Now here we can make a save plan as. So with refine region, I just name it as RR. And here with refine region, then okay. And compute it. We can now see the effect of the refine region if we have any errors or problem, or if we can fix that area that we had problem because of the cell size. Okay, now the run is finished. You can see the time step, and if you have error, you don't have error here, but if you model the sediment, then you have errors and you have more challenges. Then go to the Ras Mapper to see the results. Very well. So here, so I try to turn off the geometry, turn off this layer, and then go to overtrain. So it is better to turn off the contours. And now it's with refined region. Then we have depth. And then make it as 2, create ramp. So let's see if again we have this problem or not. But anyway, if we have it or if we don't have it, it's a way of calibration. And the first step is you have to make a really good mesh according to your geometry and your terrain. So let's start. Okay, now we have again this problem. But as you can see, the it's again occurred in the previous time, but here we have it at 2 hours and 20. So you can see the differences of these methods and the accuracy of them. So first, according to your river reach, I recommend to see what is the length of your river reach. For example, you can use the ruler and come here and see, okay, what is it? You can see the length is 50 meters, almost 50 meters. So a mesh like 5 meters or even 10 meters, maybe it's a good as a coarse mesh, of course. And then try to refine the center line of your river, then the bottom of the banks, and then the top of the banks, and then introduce the accurate flow data and run your model and enjoy your modeling. So now I would like to show you how can we modify the train. So you can right click on the train and use the clone train. It's like a virtual copy of your train, and you can change and modify it without make any change on your real train. So if you right click on this and go to the add new modification layers, you have various shapes, lines, polylines to modify your train. For example, if you have a hole or a problem in on your train, then you can use autofill no data regimes. Then you click on it, okay. So we don't have any problem on this train, but I would like to show you, for example, imagine that you don't have data here. Then you just make a modification and it use the elevation of the neighbors and interpolate the train. So you can choose a name and you can also choose the modification method, use the replace train values, higher values, add constant values, or here you can use the constant value, but these just keep the default values. And you can also always check by press F1 what is these parameters. So now I would like to run the model with make a channel. So I just go to train, then right click, add new modification layer, go to lines and channels. So by a line, we would like to make a channel. So I would like to make it as here. So you can see the name and everything. For example, I like to change the width as 15 and make this as 3, or this one as just keep it as 100. And you can see the stations and the elevations. So I like to change this to 2.3, or this one is to just 2. Then you can see the values and then okay. So we make the channels. So then I like to save it and then exit, save, and run the model. So you should go to the save plan as and make a new plan. So I made it before and then compute it. Here you can stop your simulation and you can pause your simulation. And if you want to check the results, which I always recommend to check your results before finishing the results, so then you can make a snapshot and come here to check your results. So here you can see the results or the velocity. Just need the modification of results. I believe 2D modeling of flow is easy. Then in the next videos, I will explain how to model the sediment. Then in that videos, I will explain a step by step the flow first. So you have that modeling from beginning till to the end without any tests. Here I try to explain and show you some tests without define of the mesh or with define the mesh. But in the sediment modeling, the next video, I just will show you how to model flow very fast. So you also have another video for learning how to model the flow, and then with the more focus on sediment.